The year is 1905. In the quiet Swiss city of Bern, a clock tower runs 2 minutes late. Harmless, perhaps, but those 2 minutes set off a sequence of events no one could foresee. A man living nearby wakes up slightly later than usual. His morning unfolds just a little slower, dressing, drinking coffee, stepping out the door 5 minutes behind his usual time. At that same moment, a banker climbs into his shiny new automobile, unaware that the brakes are faulty. Their paths cross, literally. The man steps into the street. The car can't stop. The impact is fatal. That man's name? Albert Einstein. And in this alternate timeline, the 4 groundbreaking papers he would have published that year, the ones that would transform our understanding of the universe, never see the light of day. Without them, the chain of innovation that brought us GPS, computer screens, semiconductors, laptops, and smartphones never begins. The device you're using right now to watch this video, it doesn't exist. Neither does this video. This is more than a tragic what if. It's a glimpse into a startling truth about reality, one explained by a concept called the butterfly effect, a cornerstone of chaos theory. It's the idea that tiny, almost invisible changes in initial conditions can cascade into enormous, world-altering consequences. And it shakes the very foundation of how we think the universe works. For centuries, we lived under the shadow of Newton's clockwork universe. According to classical physics, if you know the current state of an object, its position, its speed, you can predict its future with remarkable accuracy. Every gear in nature meshed perfectly with the next, every outcome inevitable if you knew the right variables. But in the late 1800s, cracks began to appear in this mechanical vision of reality. Mathematicians whispered that perhaps not all systems could be predicted so neatly. Still, these were whispers until 1961. That was when Edward Lorenz, a quiet meteorologist with a mind for patterns, stumbled upon something extraordinary. He was building a mathematical model to forecast weather, feeding his computer with data, temperature, humidity, wind speed, pressure, then watching it draw forecasts that, while imperfect, mirrored the real sky with surprising closeness. One morning, Lorenz decided to recheck some earlier results. To save time, he entered the starting numbers manually rather than from the stored data. He stepped away for a quick coffee. When he returned, the printout in front of him looked wrong. At first, the graph tracked the original closely. Then, somewhere in the middle, it veered off wildly, predicting an entirely different outcome. Confused, Lorenz compared the numbers. The only difference? One figure had been rounded off. He'd entered 2.506 instead of 4.506127. A discrepancy of 3/10,000ths. The kind of detail so small it could be likened to a single speck of dust on the Eiffel Tower, or one missing feather in the weight of a duck. Yet that minuscule change had completely altered the long-term prediction. Lorenz realized he had uncovered something profound. In certain systems, minute changes to starting conditions don't just tweak the outcome, they transform it entirely. And from this came the metaphor that a butterfly flapping its wings in Brazil might, through an unimaginable chain of atmospheric events, set the stage for a tornado in Texas. It's tempting to think we could solve this unpredictability if only we had better tools, more precise measurements, faster computers. But Lorenz showed that it's deeper than that. No matter how well we understand the laws of the universe, there is a limit to what we can predict. We can't measure the exact position and velocity of every atom in existence, and without perfect knowledge, our forecasts eventually dissolve into uncertainty. Yet chaos is not randomness. A chaotic system still obeys cause and effect. It just does so in ways that are exquisitely sensitive to where it starts. In Lorenz's own weather model, the shifting numbers traced out a strange, looping shape, two lobes resembling the wings of a butterfly. This was no meaningless mess. It was a pattern, a hidden structure beneath the apparent disorder. And these patterns have real-world consequences far beyond weather charts. In finance, a barely noticeable fluctuation in market sentiment can snowball into a global crisis. One reason stock predictions are framed in probabilities, not certainties. In medicine, chaos theory helps doctors understand the irregular rhythms of a heart in arrhythmia. In sociology, a single spiteful comment online can ignite a viral wave of trolling, reshaping public discourse. The sun will still rise tomorrow. Airplanes will still take off and land. Cause and effect remain intact. But chaos theory reminds us that our knowledge is always incomplete, our foresight always imperfect. It doesn't dismantle the laws of physics, it reveals their boundaries. It says, beyond a certain point, the future is unknowable, even in principle. That truth is humbling. It means we live in a universe where certainty is an illusion, and where every small choice, every subtle variation, has the potential to ripple out in ways we can't predict. Your decision to click on this video, to stay with it until now. Somewhere, in some chain of events, it will leave a mark. We just can't say what that mark will be. The butterfly effect is more than a scientific curiosity. It's a lens through which to see life itself. The tiniest kindness can alter someone's path. The smallest oversight can change history. And in a world this sensitive, perhaps the most powerful thing we can do is recognize that our actions, however small, matter more than we can ever measure.